You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Imperva helps organizations protect their data and all paths to it. Customers trust Imperva to protect their applications, data, and websites from cyber attacks. With an integrated approach combining edge, application, and data security, Imperva protects companies throughout their digital journey.
Hello, and welcome to another episode of the New Stack Makers podcast. I'm your host, Heather Joslin, features editor at TNS, and today we're talking about APIs. What are shadow APIs? What are the main features of API security? And if you're a developer, what are the best practices you should be following? Our guest today is Peter Klimek, Director of Technology in the Office of the CTO at Imperva. Peter is well qualified to talk to us about API security today. In the past decade, he also held security-related positions at TransUnion and at Kaspersky Lab. Welcome, Peter.
Thank you. It's a pleasure to be here.
It's a pleasure to have you. As we know, security is always an urgent matter in software development, but gaining urgency all the time. Imperva threat research team last month released a blog post on cyber attacks in the financial services industry, for example, and it reported that 30% of all financial services API traffic goes to shadow APIs. That's up 89% from 2021. Today's conversation is sponsored by Imperva, which provides end-to-end application and data security that protects critical apps, APIs, and data anywhere at scale and with the highest ROI. Let's get going. Peter, what API attack trends has Imperva monitored over the past year?
Yeah, so we recently, just a couple of weeks ago, we released our global DDoS threat landscape report, which is really one subset of various attacks that the APIs have to deal with and contend with. One of the more interesting things that came out of that report was application layer DDoS attacks. So ones that are really specifically targeting applications and APIs increased 82% compared to 2021. And with attacks in the financial services sector growing 121% year over year. So it really pretty substantial amount with those. And in particular, one of the things I want to highlight from that report was the layer 7 DDoS attacks themselves. The largest one that we had mitigated grew to over 3.9 million requests per second. So for most developers, when they think about their APIs, they're usually dealing with traffic that's in, maybe 1,000 requests per second, not too much more than that, 20,000 for a larger API. So to get to 3.9 million is a really staggering sum.
And you mentioned like the financial services industry, it's up even high. It was up even higher. Just the growth in number of attacks.
Yeah, and part of the reason why this is we actually saw a pretty large expansion or growth in what we call ransom DDoS attacks. And so ransom DDoS attacks are effectively the threat to DDoS an organization unless you pay some large sum of money. Financial services organizations, because they have uptime requirements as part of their SLAs and effectively always need to be available, they were a primary target of these ransom DDoS attacks. And so in some cases, the attackers don't actually follow through. But in that case of the one that we saw, that was a 3.9 million requests per second. That one was a ransom DDoS attack. And that was an instance where the financial services organization had DDoS mitigation in place. And they said, we're not going to pay it. And so the attackers did actually go through with the attack. And we saw just a sheer staggering magnitude of that. But these are the types of attacks that regularly organizations have to deal with for APIs.
What makes APIs an enticing target for cyber criminals?
Yeah, I think fundamentally, when we think about APIs, they're really just a modern interface to reading and writing or mutating data. And in particular, I kind of like to think of them more as like SQL-like interfaces. So we kind of think back to traditional DDL and DML statements that you had with SQL. And really, APIs are a way of being able to do that, but exposing that logic publicly. And so you can effectively manage and work with it. And they become a really attractive target because, first and foremost, that SQL-like nature allows querying data to be very easy. But then also the fact that it's machine readable by nature also makes it much easier for not only developers to parse, but also for attackers. Gone are the days where a attacker had to go through and they had to worry about doing things like parsing the DOM model basically for standard web pages. And now they just go and target the API itself. And then on top of that, I think one of the bigger things has been the growth of APIs has just led to a very large attack surface. And ultimately, this is one of the things that's very attractive for organizations or for attackers as whole. Most organizations, I think what we've seen is that it's not uncommon for an organization to have over 1,000 different API endpoints. And ultimately, many of these APIs themselves tend to be very poorly documented, especially if we're dealing with lots of legacy APIs. And one of the stats that I saw called out from our threat research team is that they've monitored and seen that over 45% of all traffic now can be considered shadow APIs, in the sense that it's not very well documented. The security teams don't actually know about what it is.
What risk do those shadow APIs pose as opposed to APIs that are documented, and what steps can you take to document them?
Yeah, so I mean, ultimately, what we've seen with shadow APIs is first and foremost, you can't protect what you don't know exists. Is really, I think, kind of like a fundamental truism of security as a whole. And for a lot of these are API endpoints that potentially are legacy. They might have been deprecated at some point, so they're not actively used, but they still exist because developers maintain backwards compatibility with all of their APIs, or they have old versions of a mobile app that's sitting out there and users that just have never updated it. And so ultimately, these pose a risk because sometimes they can expose certain types of data that you don't want to, or they can have certain functionality that's not intended to be used. And so that's really a big fundamental part of it. We like to look at really shadow APIs as two different parts as well. It's not just the API itself. You know, we kind of think of the top level domain that you would use to access an API in kind of one full set of API endpoints, but it's also the endpoints that compose of and make up that API itself. And so ultimately, you might have a fully and well documented API endpoint that has a GET request and maybe a POST request, but you did not document that there could be a PUT request that's associated with that. And so all of these are effectively different avenues an attacker will be able to discover. Part of the nature of APIs that also makes them attractive to attackers is the fact that these formats and the various, design patterns that developers really use is very predictable. And so it's very easy for an attacker just to try different methods and to see what's available there. And if that's not something that really is well documented or understood, they might be able to find an avenue of attack that you just don't know about actually exists.
In addition to the shadow APIs and not knowing what's out, what you have, in your system, what are some of the other big challenges that your customers experience in terms of protecting their APIs?
Yeah, I'll actually start from really kind of the different personas of the people that are really responsible for security, because I think that's interesting and they have different perspectives of the challenges that they face. So for a security team, who is the main people that we end up talking with on a regular basis, the biggest problem that they have is they just don't understand what they actually have. Most security professionals, they're not developers by trade. They can't tell you what the difference is between a REST-based API or gRPC or GraphQL or SOAP or all those other things. And then above and beyond that, even if they can, they don't live in the business logic of the API. They don't understand necessarily what the data structures look like. And so they're really kind of operating from this sense of, we have to protect everything that we have here, but we don't necessarily have the same business context that the developers have. They don't live and breathe these things on a daily basis. So for them, the biggest challenge that they really have is really just a matter of discovery. It's about a matter of understanding and getting their arms around what those assets actually look like. Now, from a developer's perspective, it's a little bit different. They, of course, know all the details of the API. They know all the details of the technologies that make up the API, but they don't necessarily have that same visibility into the threat landscape that security teams do. Developers are focused on pushing out new features and functionalities and really growing and supporting the business. They're not worried about what are the changing and evolving attack vectors that attackers are using on a regular basis. What are some new interesting, vulnerabilities that were identified in open source libraries or things like that. And so ultimately, I think for developers, the bigger challenge is a matter of education and understanding what are the attack vectors that are regularly being used by attackers that are targeting your APIs in particular.
Um, what kind of defenses should organizations have in place to manage API security risks? And question here too, like what we hear a lot about zero trust these days
Yeah.
because things live in a distributed system. They live everywhere. Does that play a role? Should that play a role?
Yeah, so I want to go back actually before we get into the defenses, kind of looking at some of the attack vectors that the developers, and I think it's helpful because it really it helps to illuminate really what the defenses should be that work with that. If we think about it, really the two biggest today that we see above and beyond just not knowing what the API endpoints are, there's effectively excessive data exposure, which is really an API endpoint that just returns more data than it should, or it returns sensitive data. And a very good, easy example to kind of describe here is a API endpoint to get user data, and it returns things like your address, and it returns, various date of birth information, things like that. And what we found from monitoring APIs is that about 12% of all APIs are exposed to excessive data exposure, meaning that they're returning back sensitive data in them. And then the second type of vulnerability that I think is really important for developers to be aware of is something that we refer to as BOLA or BIFLA, broken object level authorization and broken function level authorization. And these are not new vulnerabilities. They're actually kind of a modern take on an old web application vulnerability called insecure direct object reference. And what we found is that nearly 1/3 or 28% of APIs are exposed to some sort of authorization risk. And what this means is that effectively a attacker can go and query for information that they should not be authorized to access. And now each individual vulnerability may be problematic, but may not be catastrophic. But what we've seen is that with the largest data breaches that have been the result of an API related incident, it's usually a combination of these two things put together that ultimately leads to thousands or millions of personnel records being breached through a public API endpoint. And so I think that's really kind of one of the biggest API specific challenges that we have if we really look at kind of the details of it.
So it's this API is asking for more data than they shouldn't, or more data than they need, and then people having access, being able to query that data.
Yes. Yep.
What operational recommendations do you have for developers to manage API security risks?
Yeah, so I think ultimately it comes down to a couple of different things. So first and foremost, getting into a process of discovering and classifying all of your API endpoints is a really critical first part of it. So this is not just the API resources or the endpoints, but it's also the request and response payloads. So being able to really understand what's being sent across the API is really kind of a big part of it. The next area that we generally will look at is getting into and better understanding any sort of design related issues. So this would be API endpoints that don't require authentication, looking at excessive data exposure, mass assignment vulnerabilities, something we didn't really talk about much, but that's another one where from an operational perspective, you can really kind of identify those things. Those are some of the kind of the earlier things that I look at least initially, from just better understanding the overall risk posture of your API. But then we get into the more proactive threat mitigation capabilities. So basically being able to go and protect against malicious payloads, blocking in real time, if you will. This is really important when you think about the types of vulnerabilities that are commonly targeted, just open source vulnerabilities, if you will. So the log4shell vulnerability was kind of one that targeted not just web applications, but also APIs. You really need to buy your developers time to be able to go back and patch and apply mitigations for these types of vulnerabilities in the future. Those are some of the biggest ones, at least initially there. So I'll go ahead and I'll just pause there and see if you have any questions on those.
I want to go back to the mass identification, mass assignment. Could you explain that in more detail, please?
Yeah, so mass assignment's basically where you have an API endpoint. It returns an object of whatever endpoint you're looking to do, and normally you have kind of a mutating request, so a put or a post method, which allows you to change that object. And mass assignment's really just a matter where a attacker is able to control or change inputs that they should not be able to. So you can think of it as maybe being able to, if you have a resource that's returned and it says this user belongs to these roles, I can basically manipulate the roles in a way that I should not be able to as a user. Or I could change the underlying ID of a referenced object or permissions or things like that. And so that's one of those design related issues that you have that ultimately, when we kind of think about it, it can be mitigated. It can be mitigated by having a strong positive enforcement model. So basically saying that everything must be fully documented before we're willing to accept it. But it is still a vulnerability at the code level.
So let's delve into that a little more. Some of the things that developers should keep in mind, maybe some best practices as they design and build APIs. So just from the start, to make them more secure, what are some of the things you would suggest?
Yeah, I think really where a big focal point is for developers specifically comes in around the change management process. So you think about when you do new deployments and you push code out. So this is actually something that we implemented at Imperva in our own development teams. And it was this idea of effectively design by contract, which will be familiar to all developers, but applying it to all of our external APIs as well. And so basically what this means is that when we push new API endpoints to production, they must be fully documented. That Swagger specification or Open API specification gets updated out at the edge where we basically provide our mitigations. And if an API endpoint is not documented in there, or if any parameters are not fully documented in there, we basically block the request. And we don't let that request come through. And it takes a little bit of getting used to. It did take a while for our developers to basically get to the point where they, felt comfortable with this. But the benefit of this is that we ensure 100% adherence to what is actually documented as the expected behavior. So this is one thing that we see in more mature organizations starting to implement, and it's great to see this. Above and beyond that, a couple of the other things that we see is developers spending more time in their unit and integration tests to incorporate some of the more business logic oriented vulnerabilities in testing those. I think those points of the SDLC, basically when you're writing tests, are a really good way to validate that your authorization model is working as expected, because you have the ability to write very quick and easy integration tests that check for that. And same thing for the mass assignment vulnerabilities. You can see what happens when you basically write an end-to-end or an integration test that says, what happens when I send unexpected parameters to this API? How does it actually respond?
It's always a balance between safety and developer velocity. How have you been able to balance that at Imperva with the process of fully, having things fully documented and approved at the start of designing an API?
Yeah, it's a really good question. I think, for us, it was kind of a crawl, walk, run, as we got into it. And so it was, first just getting to a point where we had our APIs documented was a really big task. If you think about it, most organizations, especially if you're working with like a legacy API that was written before, Swagger and Open API specifications were really a commonly defined thing, they didn't even have anything. And so for us, one of the things that actually helped there was being able to not only go and to document the API, but to actually reverse engineer the API. And so we said, well, instead of having our developers write it all from scratch, because it's incredibly tedious to do and no developer wants to go and spend the time to do it, we said, well, let's just see what production looks like. And we reverse engineered our own API specification through that. And that formed the basis of our Swagger specification going forward. We were then able to basically use that, bootstrap it, and then now our developers are much more attuned to keeping it accurate and updated. But we have this regular check too to make sure that anything that's not documented basically doesn't go through. And so once they understood that, and once they understood that process of we have these hard checks and these hard gating mechanisms in place, then it really became kind of second nature to them. But there definitely was a little bit of that process initially to get to that point.
How can developers partner with security teams to tackle API security? I know some developers do feel like security teams are kind of the list checkers. I've heard them described as. They're sort of. How do you foster that that collaboration?
Yeah, I think the most important thing right away is most of the organizations that we work with, the developers have probably formed some sort of like API guild or basically a center of excellence that's really focused on developing best practices and standards for the organization.
Mhm.
Make sure your security team is a part of that. I think really from two different perspectives. The first one is the security team gets a better understanding of what the actual concerns are, what the challenges are for all of the API developers. But then at the same time, it's an opportunity for the security team to better educate the development teams around the different types of threats that they're actually seeing. And we've gone into some of those organizations and we've done presentations around what does the threat landscape look like, what are some of the core vulnerabilities, and done deeper dives. And we're happy to go and help consult with those environments and work with those teams. But I think that's really kind of the best avenue that we've seen it. And then above and beyond that, security teams are always looking for developer champions. I think that's kind of the key thing is for every organization, you probably have hundreds of developers, but only a small handful of security teams. And so, really, this process of deputizing developers to take more of the security into their own hands is something that no security team is going to say no to.
How would you identify a security champion among your developers? What are some of the traits you'd look for?
I look for passion, to be totally honest. I think security in particular, there's certain people that just absolutely love it. They're really kind of intrigued by the way that APIs will be abused. They're really intrigued by the various threat vectors and kind of learning about this world. And so, for any developers out there that show an interest in this, I think for security teams, that's where you jump at it. That's where you look for those people in particular that want to get into the weeds. They want to better understand kind of the seedy underbelly to how applications are attacked. And I mean, that's how actually I got into security. I had formerly a developer and admin role. And I was just really curious about security. And so I started just like talking to our security guys and kind of getting involved a little bit more. And before I knew it, I was on the dark side.
So, pretty interesting journey there.
Mhm.
Is there anything else that you can think of that our audience should know about keeping their APIs safe?
Yeah, I think probably some of the bigger ones that we run into right now is really this automatic assumption of the operational tools that we have in place are going to protect whatever we cook up. I think in particular where this comes into play is a lot of the security tools on the market have done a pretty good job at keeping pace with REST-based APIs because they basically are so prominent now. But when you start implementing gRPC and GraphQL in particular, this is where there is just a mile of difference between different security solutions on the market and what they can support. And so I think not making these assumptions right out the gate that whatever developers are moving to is going to be automatically protected, I think is one of the core things. And then above and beyond that, I think you also have to understand that the threat model for those environments is also different. We could do an entire podcast just talking about GraphQL and the challenges with that because it's so much more SQL-like than even REST-based APIs are. And
Mhm.
one of the bigger things that we've seen there is just how much and how difficult it is to mitigate things like application level denial of service with GraphQL APIs. So lots of different challenges around there. I think before you go and adopt the flashy new technology that you just read about at a conference, just kind of understand that the security side of it might be a really, really big challenge that you haven't quite taken into account for.
What are some of the questions you should ask if you're looking at at solutions for protecting your APIs?
Yeah, so I think the biggest is getting into the nitty gritty of what type of payloads does it actually protect. Understanding because GraphQL and gRPC in particular are completely different. gRPC you're operating over it's binary over HTTP2 basically. A lot of web application firewalls, traditional WAFs cannot inspect that. Same thing with GraphQL. The structure of GraphQL payloads looks completely different, and so most WAFs can't actually protect against that. There's been this shift in the market of moving away from web application firewalls towards, or differentiating at least between web application firewalls and web application and API protection solutions, or WAP, if you will, as Gartner coined it.
Mhm.
Ultimately, the reason, terrible name, by the way,
Yeah, yeah.
But the reason why they did coin a separate category for it was because what we found was that really it was not all solutions were alike, basically. And it did require this differentiation between the two different solution sets. Above and beyond that, I think one of the other things to think about too is not having a solution that's actually dictated by your infrastructure. So every organization that I talk to, they don't use just one type of API gateway. They use 5 different ones. And so you want to make sure that your security solutions aren't tightly coupled to either the API gateways themselves or to the cloud service provider infrastructure, because pretty much the same thing. Everyone's multi-cloud. And if you're not multi-cloud right now, you're going to acquire a company that doesn't use your cloud. You're going to become multi-cloud.
Yeah. We'd like to thank Peter Klimek for joining us today. And we'd like to thank Imperva, the sponsor of today's conversation. And we'd like to thank all of you for joining today. This has been Heather Joslin for the New Stack Makers. We'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.